Hello everyone. In this video we will learn how to find a distance traveled in between a given time interval when we are given the acceleration function and an initial velocity. Alright, so let's read the question first. The acceleration function in meters per second squared and the initial velocity are given for a particle moving along a line. Find the velocity at time t, the distance traveled during the given time interval. Okay, so to find the velocity function at time t, we will have to integrate the acceleration function, right? In other words, acceleration only means the derivative of velocity gives us the acceleration, so we'll have to work backwards, right? So v prime t is our acceleration function. Okay, that means if we take the integral on both sides, we will get our velocity function. And then we'll have integral a d dt. So our velocity function would become then the integration of t plus 4, right? So integrating t plus 4 will be just t squared, and the exponent comes down to the bottom, t squared by 2, plus we have a constant 4. That means 4 will now have a t with it, plus a constant. So this constant is already given to us, isn't it? The velocity at time 0 is 5, which means the particle was already moving at 5 meters per second when it was even starting at time 0. And so that will mean the c can be replaced with 5. That is 5. So there is the first part. All right, now the second part, we'll do the same thing. We know that to to find the distance from the velocity function, we'll have to integrate the velocity function again to find the distance. And to go from distance to the velocity function, we take the derivative of the distance function to find velocity, right? So again, working backwards from velocity to distance, we will have s prime d velocity function. This means taking the derivative of distance function will give us the velocity, right? Now we'll integrate both sides. S t. And integration of the velocity function, which is this t squared by 2 plus 4t plus 5. If we take the integration of that, we'll get t cubed divided by 3 times 2, 6, plus 4t, right? So that's going to become 4t squared by 2. So the 4 and the 2 will be reduced. We'll have a 2 and then t squared plus 5t. So that's our distance function. All right, now since we have that, we also have to put the boundaries in it. It will be 0 and this will be t. That's a time interval, and this is the boundary, 0 and 10. Okay. Now we'll just plug in these values and then we can find our distance covered in the time interval of 0 to 10 seconds. So this will then just be t cubed, and there's 10, so it's going to be 10 cubed, which is 1,000 divided by 6 plus 2t squared. Now if you plug in t in there, we'll get a 200 plus 5t, so 5 times 10, which is 50. Now we have to subtract all of it when we plug 0 for t's now. So if you plug 0 here, it's just 0 by a number. And then over here, 2 times 0, 5 times 0. So basically it'll just be 0. Which means we'll have, if we add all of this up, we're going to get 2,500 over 6. which is 416.67 meters in the time interval of 0 t to 10 seconds. So this value is the amount of distance that the particle covered from time 0 to t when the initial velocity was 5 meters per second. And we got this by taking the integration of acceleration 2 times to find the distance function, and then we just plug in the time interval for t. That's how we find the distance covered. I hope this video helps. Thank you for watching. Take care.